Hello and welcome back to my channel. In this tutorial I'm going to explain an anomaly detection example with optics method in Python. Ordering points to identify the clustering structure is a density-based clustering algorithm similar to dbScan. It's used for estimating the density-based clustering structure in a data. In this tutorial, we'll briefly explore how to apply the optics method for detecting anomalies in a given dataset using the optics class from the Scikit-learn library in Python. In this tutorial, we'll cover the following steps. Understanding the optics, here I'll give a brief explanation of optics and its suitability for anomaly detection. And preparing the data, we'll generate synthetic data using make-blob function. And anomaly detection with optics, we defined an optics model and explain how to identify anomalies in a data set. And finally, I'll provide a source code listing. Optics is primarily a clustering algorithm, as you may know, but it can be adapted for anomalies detection due to its unique characteristics. Optics identifies dense clusters, making it well suited for identifying outliers in sparse regions, which are often anomalies. Optics reveals the hierarchical structure of clusters. It can help differentiate between anomalies within smaller clusters and those in larger clusters. This model automatically determines the clusters, making it flexible for changing cluster size and shapes. Noise points are those data points that do not fit into any cluster, and this can be useful for anomaly detection as they often represent outliers. Before we begin, we'll load the required libraries and functions for this tutorial. Here we use Scikit-learn cluster, datasets, NumPy, and Matplotlib libraries. We'll start by generating the synthetic data using make-blob function and visualize it in a scatter plot. Here we generate random data and visualize it in a plot. And this is the target data for us to identify anomalies here. Next, we'll apply the optics algorithm for anomaly detection. We'll define the model, obtain core distances, set a threshold for anomaly detection, and identify anomalies in the data. We'll define the model and fit it on X data, and we'll get the core distances and set a threshold. We'll extract the threshold value from the scores data using the quantile function. In this example, we'll consider 98% of data as normal, and the remaining portion will be classified as outliers. You can set your target percentage for quantiles. With the threshold value, we will identify samples with scores equal to or higher than the threshold. Finally, we'll visualize the results by highlighting the anomalies in a plot. And this is the output. Here we detected few anomalies and highlighted them in a red color. That's it for this tutorial. In this tutorial, we have introduced you to the optics algorithm for anomaly detection using Scikit-learn optics class in Python. You learned how to prepare data, apply the algorithm, and visualize anomalies. And the source code for the entire tutorial is provided below. Please visit my website and you can get all the source code and information we have covered here. Please subscribe my channel and hit like button if you like this video. Thank you for watching and see you next time.